And there's been a lot of work undertaken on the ground over the last couple of years in preparation. With the mining license granted, what would be your aspirational view for development schedule?
So right now we are progressing, obviously, the development of a demonstration plant in Uganda. We anticipate producing mixed rare earth carbonate this year. Producing that mixed rare earth carbonate is going to be important for our supply chain partners and where that product potentially goes. The ability to work through final investment decisions is going to require, obviously, successful outcome of the demonstration plant, commitment of the product to a supply chain, and then working through the financing. In my opinion, committing the product to a supply chain then creates the opportunity for the strategic funds to come in from that jurisdiction, because there are a number of government funds that have been set up in order to secure the materials, secure the feedstock to develop the processing of rare earths for their jurisdiction. So, we are engaged with several groups on this that have indicated their desire to get access to the magnet heavy rare earth product that would come out of Makuutu. And right now we're working through what is the mechanism under which that material would be processed, noting that we are conscious in trying to make sure that we have the most flexibility for the development of a larger Makuutu by trying to look at processing, so separation, refining, metal alloy manufacturing, all outside of China. So it's reasonably well advanced, and we hope to be able to talk about that shortly.
And Tim, on that potential development and the testing from demonstration plant material, do you foresee offtake partners cornerstoning some of the capital required?
I do see the ability for strategic funds to come in to put their foot on the product, because simply put, there is no advanced manufacturing without the feed molecules. If we look at Makuutu's role in developing supply of heavy rare earths, specifically dysprosium and terbium, to facilitate the development of sintered magnets for electric vehicles and wind turbines, then Makuutu is in a very unique position in that it is the most advanced ionic absorption clay project outside of China and Myanmar that as yet does not have its product committed to China. So if we look at the importance of Makuutu, it is a very strategic project in being able to facilitate new supply chains emerging in Europe and the US, for example.
And we're well aware at the moment in Australia of lots of rare earths projects, exploration, some good results around the globe. Makuutu at the moment it was safe to say, is a leader in this global race to get into development stage and become an operating project. Can you give us a bit of an overview for new shareholders or those that need a bit of education, the product that you're looking to produce, the target assemblage of lights versus heavies, and where Makuutu sits in potential to other Western projects that are looking to fill this demand?
Yeah, so I mean, the big appeal for Makuutu is the proportion of both magnet and heavy rare earths. So when we talk about magnet rare earths, the elements that we're really talking about are praseodymium, neodymium. So a lot of investors will be familiar with NdPr, right? NdPr represents about 50% of the revenue of the basket from Makuutu. What's quite often overlooked is the requirement for both dysprosium and terbium. So dysprosium and terbium are heavy rare earths. 98% of the world's current supply comes from China and Myanmar. It comes from similar deposits to the ionic absorption clays of southern China and Myanmar, so similar deposits in Makuutu. And so, the importance of bringing on new supply of dysprosium and terbium is incredibly important for the development of sintered magnets for the application in EVs and wind turbines. What Makuutu also has is it has the ratio of magnet rare earths in about the right ratio in order to develop sintered magnets. And beyond that, we also produce, and we have about another 10% of our basket being additional magnet rare earths. Now, these are rare earths that go into other magnets such as samarium, cobalt, but also importantly, gadolinium and holmium. Gadolinium and holmium can be used in substitution for dysprosium and terbium to some degree. And certainly the work that we've done with Ionic Technologies, we understand the roles in which the full spectrum of magnet rare earths have been used in different applications. And that gives us a lot of confidence in our thoughts about the importance that Makuutu plays in developing ex-China sourcing. Beyond that, there's a suite of other rare earths that we produce, heavy rare earths that will find a natural home in key geopolitical industries, specifically military and defence. So we see ourselves perfectly aligned and leveraged to the geopolitical climate in providing, secure, sustainable, traceable, non-Chinese magnet and heavy rare earths.
Thanks, Tim. Pretty good education there for those of us who are constantly bewildered by the changing landscape of what we're seeing in the rare earths industry and what needs to be supplied and where you sit.